Welcome, Vanakkam, Hola, Bonjour, all the minions. Welcome to the next session of Waves, where we are going to talk about light as a wave. And everybody might have had some kind of ideas in their mind regarding what exactly is light. So we're going to see light as a wave today. And we are also going to see some interesting principles like Brewster's law, polarization, intensity of light, and how this is used or how is it applied in our day-to-day life. All this with me, Shreyas, your master teacher for physics at Vedantu, and also on this channel, Enthuse. Enthuse is a very special channel because it is dedicated for all those aspirants who want to crack the JEE examination, BitSat, CET, boards, etc. and that too in English medium. So that's the speciality of this channel, because there are hardly any channels in India which teach all this stuff in English. So welcome aboard. Hello Binyan, Aarti, hello Anthony, hello SP, hello Yalini, Dinesh, Saktivel Vlog, hello Ankit, hello Priyanka, hi Diya, hi everyone, hello Aishwarya, hi. Good evening, hello Xavier, good evening everyone, good evening everyone. I hope you guys are all excited for today's session, and in case some of you are new out here, please get involved in the chat box. Make sure that the chat box is interactive, and if some intruder comes who is trying to create some kind of nuisance or spamming, you know what to do. Yes, block him or basically report it. All right, so make sure our family stays healthy, our family stays neat, clean, because we are a lovely, wonderful family who help and support each other. Yes, let's begin with our class. And those of you are new, they can also follow me on my Instagram handle, which is Shreyas_Vedantu. So do check it out for more videos, posts, motivation and stuff like that. And if you are new, do not forget to hit the subscribe button, because that's for free of course. So go hit the subscribe button so that you get more updates and all the important notifications, videos, etc. for your upcoming examinations. And if you have done that, hit the like button as well. Go ahead, do that, because I need that energy to stand here to conduct all these sessions for free, dedicated for you guys out here. So come on guys, go smash that like button. Hi Saurabh, hello. Yes, we are a JEE family, we are a minion family, we are a lovely family, Dinesh, everything. Hello Anthony Abi, good evening everyone. Yes, thank you. Yes, welcome Xavier. I'm always there for all of you so that you get quality education, and we want to spread it throughout India. That's our motto, because not many people are doing it. By the way, this is the schedule for this week. We are going to complete entire waves in these one shot plus marathon sessions. So tomorrow, do not forget standing waves, Doppler effect and beats, 7 o'clock. All these lectures are at 7 o'clock. Keep this in mind. Okay, so all these lectures are going to be at 7 p.m. Okay, and day after tomorrow, Young's double slit experiment, diffraction, interference of light. That's what is going to happen on Thursday. In case you have missed transverse waves on a string and sound waves, please watch the replay of the previous lecture. Thursday, Friday and Saturday, I'm going to start modern physics, and most of it will be done, like you can see, right from photons, photoelectric effect, X-rays, atomic structure and nuclear physics. Semiconductors, etc. I'll probably try and do it next week. And mock test on Friday, again discussion. So keep this in mind. Some lectures are at 10 o'clock. Keep that also in mind. Also on Sunday, you're going to have a Valentine's Day special. I don't know what it is, but we will have it. Okay, so let's begin with our class, guys. Hello. Yes, Diya, I think transverse and longitudinal waves is important, because every time one question comes from it, and usually that is easy. They fall under easy or medium category. So because you can crack it, why should you leave it? Always go for the easy target. Yes, correct? So do not go for very difficult problems. Thank you, only textbook. Love you too. I love, in fact, everyone. Yes. Thank you, Dinesh, and welcome. Let's begin with our session. Now, is light a particle or a wave? So, people like Newton and Einstein thought that light is basically a particle. There are many people who propagated this idea, and they were also true in a way because the experiments suggested that light also behaves like a particle. Like it has momentum, it can exert force, and so on and so forth. So all these are characteristics of a particle. So light does exert force, light does exert momentum. But at the same time, light also shows properties like spreading, which is diffraction, interference, or refraction, and all these things. These are basically essentially characteristics of a wave. So people like Huygens, Maxwell, and all these people, Young's, they believed that light is a wave, and there was always a war, and then it was finally concluded that light behaves as a particle and a wave depending on the scenario. So it has a multiple personality disorder, in fact a dual personality disorder. So whenever required it will behave like a particle, and whenever required it will behave like a wave. So that's how light is. But today we are not going to go on and debate whether light is a particle, wave, and how this works and stuff. Today we are only going to focus on how the characteristics of light as a wave are. So we are going to see the wave characteristics of light. That's what we are going to do. Yes, thank you Sakti. Welcome everyone, all the people who are joining in late. Welcome, welcome. Yes, so I don't know what will happen in the future as well. Alright, so we're going to start talking about light's characteristics as a wave. Now this chart is very important chart. Don't worry, this chart will also come in the PDF. If you have already joined the Telegram group, this PDF will be already there by tonight. Don't worry. But this is very important chart which you should memorize. Yes, you should know which wavelengths are in which region. Which wavelength is more, which wavelength is less. What is the approximate range of frequency or wavelength? You should know this. This is called as the electromagnetic spectrum. These are different waves of different wavelengths, but only a small part, like you can see, is visible to us, right from red to violet. Alright, so whatever colors fall between this region, that's what is generally visible to us. Orange, indigo, blue, green, yellow, all these things are visible. Apart from that, beyond this you have ultraviolet. Here you have infrared. So infrared has larger wavelength, more larger is microwave, more larger is radio waves. If you go on that side, the wavelength becomes shorter. You can see that from this pictorial representation. Ultraviolet is even shorter. Beyond ultraviolet, you have X-rays, which has even shorter wavelength, about 1 angstrom. You can see X-rays are 1 angstrom roughly. And beyond that, you have gamma rays, which are even shorter. Remember, shorter wavelength means more frequency, and longer wavelength means high frequency. Keep that in mind, because lambda and frequency are inversely proportional to each other. So this is how it works. So radio waves are very long, in the order of couple of meters, and as you go below, it goes to micrometers and then angstroms and even beyond that. All right, very, very important. Very, very important. Okay, so I hope you have made a mental picture of this. This is just for your comparison, that how long it is. You don't have to actually remember that, oh, it is protozoa, oh, it is molecule, oh, it is atom. This is just for giving you a rough idea how small the wavelengths are. That's it. Now, having said that, how does light travel like a wave? So, we all know if you take a string and you generate a pulse, that pulse beautifully travels on that string. We have seen that, in fact, in the past lecture. Now, light travels as an electromagnetic wave. That means there is electric field and magnetic field simultaneously traveling, mutually perpendicular to each other, and traveling with the same speed, same wavelength, and same frequency. So two things are there: electric field and magnetic field perpendicular, and they move simultaneously. That is what is light. So when you are seeing everything around you, you know what is it? It's electromagnetic waves. Yes, everywhere around you, whatever light, studio lights falling on me, the light coming from this board, everything is electromagnetic waves. Yes, and this is how it looks like. The blue one over here is electric field. The red one in the perpendicular plane is the magnetic field. You can see that. And see how beautifully the wave travels. Now, what it also means is, if you stand over here, example, you will see the electric field will continuously keep on changing. It will continuously keep on changing like a SHM, and the magnetic field will also simultaneously keep on changing in the perpendicular direction at any given point. I hope this makes sense. Alright, so that's one thing. Now one more thing I want you to see. Can you see that this wave is traveling towards your right side? Do you see that this wave is traveling towards your right side? Cool. Now use your right hand rule, cross product rule, and think about it. If I take the magnetic field is here, let's say at some instant, magnetic field is here, electric field is there. Electric field is there, magnetic field is here. E cross B, electric field cross the magnetic field. Do that. Electric field, I'm assuming you are, I'm a student and I'm trying to move my hand as if you would do. Electric field is on the top, magnetic field is here. Do you see my thumb going there? That's exactly the direction of the electromagnetic wave. So remember this, electric field cross magnetic field always gives you the direction of the wave, of the light wave. Correct. Yes, that's how it is. Yes, you should not learn CJ clicks all the wavelengths, but certain wavelengths like X-rays, visible spectrum, infrared, ultraviolet and gamma rays. Basics, just the main stuff, and long radio waves. That's all. Cool. So that is one thing you should keep in mind. So having said that, let's have a look at the wave equation. Just like in transverse waves, from one crest to next crest, that would be the wavelength. You can see a wave like this. So that's a wavelength. Or from one trough to the next trough. It doesn't matter. Both the wavelengths will be the same. You can also calculate the wavelength for the magnetic field. It doesn't matter. Both waves are simultaneous. Remember, I have told you that a normal wave equation looks like this. For a sinusoidal wave equation, it looks like this, sine of kx plus minus omega t. We have seen this. Y is the displacement of the particle, A is the amplitude, k is the angular wave number, omega is the angular frequency. But in case of electromagnetic wave, what is that thing which is going up and down? It's either electric field or it is magnetic field. Hence, this equation will be rewritten as electric field. Okay, electric field will be E naught sine, alright, kx plus or minus omega t. That's the magnitude of electric field as a function of time and position. At different points, at different times, the value of E will change. So what is this E naught? This is the electric field. This is the electric field amplitude. Keep this in mind. Maximum value is the maximum value of the electric field. Similarly, think about it, the magnetic field, guys. The magnetic field will have a similar equation. B is equal to B naught sine same k x plus or minus omega t. Alright, that's how this works. This is how the equations look like. What is B naught? B naught obviously will be the magnetic field amplitude. Keep this in mind, magnetic field amplitude. Having said that, also remember k is nothing but 2 pi by lambda and omega is nothing but 2 pi f. We have already seen this. This is in radian per meter and this is in radian per second. We have seen this. Correcto? Yes, this is the maximum value. Correct. Now, also remember this plus and minus convention. I have told you this before. If it is plus, then it is going along the negative x-axis. The wave is traveling along the negative. Remember, it's always opposite. And if it is minus, then it is going along the positive x-axis. I hope all the minions have made notes of all of this. Very, very important. Very, very important to make notes, because the questions when they come, they will be simple. And believe me, last few years, there has been, a considerable increase in the number of questions asked from this chapter. And you will see that. I'll be taking so many questions from previous years also today. Yes, throughout the lecture. And you will see why this chapter is important, because it is scoring. If you know all the formulas, if you miss even one formula, maybe you might not be able to do that problem. Correcto. Let's get going. Yes, Muhammad. Yes. All right. Let's get going. Moving to the next part. Now that we have spoken about the wave equation, I want to talk about the speed of light. Speed of light formulas, guys, very important. Many times you will see a lot of questions on speed of light, and we all know light travels really fast. So here it comes. Speed of light, first formula, lambda into f. That's standard, you know this. Lambda is wavelength, f is frequency. Lambda is in meters, f is in hertz. So you get the speed of light as meters per second. Now the speed of light in free space, everybody knows this, is roughly around 3 into 10 to the power 8 meters per second, which is 3 lakh kilometers per second. 3 lakh kilometers per second, or 3 into 10 to the power 8 meters per second. That's not it. There are some additional formulas which you should know now. These are new formulas. Listen to it. C is also the value of electric field by magnetic field at any instant, which is also, think about it, E naught by B naught, because the sign term here and here will cancel out, because electric field is E naught sine something, magnetic field is B naught sine something. That sign will cancel, and this is also equal to 1 divided by mu epsilon. So what is this mu? This mu is nothing but permeability of that medium. Permeability, we have seen that. And what is that epsilon? That epsilon is nothing but permittivity of that medium. Think about it. All right, so these are the additional formulas that you must remember. There is no option, there is no negotiation of not remembering this. Keep all these things in mind. And the last thing, which I had already told you, but still I'll mention about it here again. If you take electric field cross magnetic field, if you take electric field cross magnetic field, that direction is parallel to the direction of the speed of light. Very important. They're having questions even on this. Yes. Electric field is up, magnetic field is there. E cross B, okay, will be the speed of light. All right. So that's how it will work in that case. I hope this is clear. Everyone understood? Cool. Shall we go ahead? Yes. Shall we go ahead? I hope you have made notes. I hope you guys have made notes, all the minions. Cool. Clear? Let's get going. Let's start with some problems now, guys. Yes, let's start with some problems. Here it comes. Speed of electromagnetic waves is same in, or rather for all the wavelengths, in all the medium, for all intensities, for all frequencies. I don't know how many are correct or wrong, but you guys guess and tell me speed of electromagnetic waves, or basically light, is same for or in which of the following options? Yes, I think in the image that speed of light was marked in a wrong way. Yes, Muhammad Rahil. But remember, that rule is E cross B is C. Don't worry about it. All right, some of you are saying B, some of you are saying C. All right, minions. Arey, SL is saying ABCD. Acha. Most of you are between B and C. Okay, minions, time to see the answer. Let's see what the correct answer is. There we think about it. Light. Does it depend on the wavelength or frequency? Do you remember prisms? In prism, do you remember each color bent by different amount, deviated by different amount? Why did violet and red deviate by different amount? Because they have different refractive index. Think about it. Because they have different refractive index. Do you remember that? That means, think about it, frequency of violet or wavelength of violet is different from the frequency and wavelength of red. So, the moment frequency changes or wavelength changes, the refractive index will change. And don't you remember, guys, speed of light is also dependent on the refractive index. That means Think about it, frequency and wavelength will decide the speed of light. How about medium? Oh, obviously refractive index is dependent on the medium. If light enters a different medium, the speed of light will change. But intensity? No. Just because you have more light does not mean it is going to be like, hey, I am more, I am going to travel faster. Or if you have a faint light, okay, this is hardly any light, I am going to travel slowly. No, it's not going to be like that. It's going to travel with the same speed. So guys, understand, for all intensities, speed of light is same for all intensities. Yes. Correcto. Understood, guys? All the minions up for this? Shall we go ahead to the next question? Very good. Here it comes. Next question. Try and do this simultaneously. I will also solve. So there is relative permittivity, which is 2.14, relative permeability, which is 1.3. What is the speed of light in this particular medium? That's the question. That's the question. Come on, minions, let's do this. And some of you who want to do it before me, no problem. Go ahead, do it. Because I'm going to solve it slowly for all the others who want to see this step by step. Okay, so we want to know what is the speed of the wave. Here it comes. The speed of a wave, we just know it is root of mu epsilon. Isn't that right? Now, relative permeability and relative permittivity is given. So think about it. If I wanted the speed of light in vacuum, which is C naught, it will be 1 by root mu naught epsilon naught. Mu naught and epsilon naught are permittivity of free space or vacuum. Now just divide both of them. You will get C by C naught is equal to root of, see, think about it, C naught, it's inversely proportional, right? So it will be mu naught epsilon naught divided by mu epsilon. Now what has been given to us is the relative values. So let's do this. C will be equal to C into root of, think about it, this mu is 1.3 times of mu naught. Think of it this way, relative permeability. So this mu over here is 1.3 times of mu naught, and this epsilon is 2.14 times of epsilon naught. So 2.14 times of epsilon naught. So this will become C naught. Now what is C naught, guys? C naught we just know it is 3 into 10 to the power 8. Mu naught, epsilon naught goes, and you will have root of 1.3 multiplied by 2.14. Now this is just a matter of calculations. Just do that calculation and see what is the answer that you get. So this is just, oh my god, many of you have already answered. Looks like C. Yo, very good. Excellent, guys, excellent, very good. Yes, the correct answer, almost this comes out to be around 1.79 into 10 to the power 8 meters per second, roughly. So 1.79 into, into 10, yeah. So I think this should have been, yeah, there it comes. Option D, check it out. Many of you said C. Now, especially for all those students who are in 12th standard and who are finding it difficult, to cover up the backlogs, and who are confused how to study for boards and for JEE simultaneously, all right? And probably you want some kind of test series because maybe in your coaching you do not have that national-wide test series, plus you want some test discussion, which is very important. We have made a very nice plan so that you get testing, and also if you are not having any mentor or personalized care, let's say for solving all your doubts, we have created a plan for all of you so that your doubts get cleared. Also you get enrolled into test series and these tests get discussed. Plus all the portions will be completed in this plan, where we are going to start with 11th standard and 12th standard syllabus, complete revision systematically by relating all the topics. That's one thing. Also, you are going to get notes of every lecture, handwritten one, and guys, you can watch the replay after every class. Yes, you can watch the replay after every class. So even if you miss, or let's say you do not remember what sir said or ma'am said, you can always check the replay so that you can revise it again and again, which cannot happen in offline. You cannot ask the teacher, hey, come on, start telling again. So that's one advantage. Second thing, even if you miss, there is no problem. Also, the test series are going to be conducted where you are going to have 15 full syllabus plus 5-part test series with all India rankings. That's very important, so that you know where you stand and how much you need to improve. That's very important. It's not like a local rank that you get, it's an all India rank, because you're competing nationwide at Vedantu. And best part, you get doubt solving in the class when the teacher is teaching, and also after the class from morning till night. Ask any doubt, it's okay. Ask NCERT doubt, ask PYQ doubts, ask any doubt, it's okay. You get your doubts cleared, because you need someone who is there for you. No? You cannot rely on your friend or some random person and get a response after 3-4 days. You want your doubts to be solved quickly because you don't have time. So all this in the crash course, which starts every Monday. So guys, don't worry, even if it is Tuesday or Wednesday, don't worry, you have hardly missed 1 or 2 lectures. Please understand, you can watch the replay. So join the crash course. The link is in the description box below. And the course price usually is 10,000. But when you use the coupon code SHCC, then you get a deal of 8,000 rupees, 20% off that is. So I think it's a very good deal. You should definitely consider this. Watch the link below in the description box. Check out all the details. Join it right now, today, so that there is no further delay in your preparation. Remember, if you clear your mains in the second or maximum third attempt, you are free to start practicing for advanced. So that's what I feel. So think about it. Next, 2020 question. In a plane electromagnetic wave, the direction of electric and magnetic fields are k hat and 2i cap minus 2j cap respectively. What is the unit vector in the direction of the wave? That's how it is. That's how it is. Come on, think. Think. All right. Come on. A day, how many hours of study is enough for JEE Mains 2022? Santosh Kumar, I feel you should solve or sit for self-study for at least 4 to 5 hours every day if you want to crack it for next year. Minimum 4 to 5 hours apart from coaching and school. That's what I say. Good SL. Okay, so let's see how to solve this. Now, remember, I have just told you that electric field cross magnetic field is parallel to the speed of light. That's what I told you. Now, what and all is given? Electric field is k hat. Okay. And magnetic field is how much? 2i minus 2j. So first of all, let's see what will this be. In case you are having a hard time calculating this, remember this circle. In this circle, when you go clockwise, it is positive, and when you go anti-clockwise, then it is negative. Keep this in mind. That's it. Then you will be able to do it. K cross 2i. K cross I is j. So it will become nothing but 2j hat. Okay. Minus k cross j. K cross j, you are going like this, anti-clockwise, it will be minus I. So it will be minus 2i. So eventually it will become 2i cap plus 2j cap. Now think about it. 2i cap, 2j cap is parallel to which of these vectors? Obviously there is k here. Obviously this is wrong. Here there is I plus 2j. This is also wrong. 2i plus j. This is also wrong. This one, yes, same coefficients. So this will be correct. So this is definitely parallel. This is parallel. It's not equal to, but parallel to this vector. So hence the speed of light will be A. Option A. I hope this is clear. Understood, guys? Hello, Dharma Perunwal. Welcome to the channel. All right. Yes, unit vector is asked. So that's why that. Cool. Let's get going. Next question. Option A. Cool. Let's get going. 2020 question. Magnetic field is given. The wave equation of magnetic field is given 3 into 10 to the power minus 8. 200 pi y plus ct. Be careful, there is y here, not x. usually it is x, where c is this much. What is the, c is the speed of light, okay, the corresponding field equation. Now I'll tell you how to solve this problem step by step. See, if magnetic field is given, speed of light is given, you can find electric field's magnitude or amplitude, sorry. So from here, think about it, B naught is 3 into 10 to the power minus 8. Look at that, B naught is 3 into 10 to the power minus 8. And I just told you about this, E naught by B naught is C. Therefore, E naught will be C, which is 3 into 10 to the power 8 into B naught, which is 3 into 10 to the power minus 8. Now 3 3s are 9. That 10 to the power 8, 10 to the power minus 8 goes, so it will become 9. So check the options which has 9. You can see these two options automatically get eliminated. So cross B and C out of the way. Next, see whatever is there inside. The same thing must be there inside. Is it? Yes. 200 pi y plus ct, 200 pi y plus ct. Yes, both of them are same. I hope this makes sense. Now, if this much is clear, think about it. Let's see, what do we do? Okay, one second, I'll use this color here. Okay, now the only thing is this I cap, K cap and all that. We need to get rid of that. So again, go back to electric field cross magnetic field is parallel to speed of light. Electric field cross magnetic field is speed of light. So guys, electric field, I don't know. That's the big question mark. Cross magnetic field, it's in I cap direction. All right, it's in I cap direction. And speed of light, where is it? Speed of light. Oh, look at it. The wave is going in the y-axis, guys. This is very important. It's going in the y-axis. But is it going in positive y or negative y? Come on, answer in the chat box. Is it going in positive y or negative y? Be careful. It's going in positive y or negative y. I feel it is going in negative y, because when this is plus, it is negative. Remember that. So it's actually going in negative y-axis. Negative y-axis. Think about it. Just like when it is kx plus omega t, it goes in minus x. Kx minus omega t, it goes in plus x. So it is plus here. So that's why it is going in minus y-axis. So it is having minus j cap. So guys, now the question is very simple. If I have I, j and k, what cross I will give you minus j? What cross I gives you j, minus j? Think about it. K cross I will give you plus j. So I think this question mark must be minus k hat. Do you understand it? It should be minus k hat. Correcto. So hence, do you see this minus k hat here? Minus and k hat. There is no minus here. So option A is wrong. Hence option D is correct. That's how you do this. Very interesting question. I have solved it step by step so that you understand every bit of it. Some of you could have solved it before, but that's not the point. I want to discuss it for all the minions out here. All right, let's get going. Very good, Yalini. Very good. All the people out here. Excellent. Now, next, let's go to intensity of light. Very important formula. Remember, when a source of light emits radiation, as it spreads, their intensity keeps reducing as you go far. What is intensity? I have told you before. Remember, intensity is nothing but the average energy flow, all right, per unit time, per unit area. So basically, the units will be watts per meter square. How much joules falls per second per unit area, per meter square. So when you go far away, that energy will now be distributed on a larger surface. So per unit area, you can see the energy gradually decreases. So that's why when you stand far from a light source or from a fire, the intensity is less. And when you go close, that will be more. Okay. So what is the formula? This is the formula. Intensity is half. Keep this in mind. Half is always going to be there. E naught. Okay. B naught by mu naught. This is one way of writing it. But also remember, I have just told you E naught by B naught is equal to C. So if you want, you can write only in terms of E or B. So what you can do is write it as half B naught into C into B naught by mu naught, and then this will become half B naught square C by mu naught. This is also another way. So it's up to you how you want to write it down, but I prefer writing it this way and then arranging it depending on whether electric field is given or magnetic field is given. It's up to you. These substitutions can be done. Half E naught B naught by mu naught. Keep this in mind. All right. So is that called attenuation? In a way, it is not exactly attenuation. Attenuation is when you have some light or some sound or some wave falling and you absorb some quantity of sound or light. So the sound which comes out is less than the original one. That is called as attenuation. That's the meaning of that. And amplification is the exact opposite. You absorb something and you amplify it. You make it more. Okay, that's the meaning of that. Cool. So having said that, let's go to the next point. Radiation pressure. Very, very important formula. If light falls on a surface, it exerts pressure because the photons, the waves are colliding and it exerts some force. That force per unit area is called as the radiation pressure. So keep this in mind. So radiation pressure is the force by the radiation, the force by the radiation per unit area. Obviously the units will be Newton per meter square, or you can also use Pascal. That's the formula. Now if this is the light falling on this area, the pressure when the light gets absorbed, imagine a black surface like my t-shirt. If light falls, everything gets absorbed. Then the formula for that, keep this in mind, is I divided by C. Very important. The pressure is intensity. This I is intensity. This C is speed of light. Okay, so keep this in mind. This I stands for intensity. Intensity. Okay, and this is nothing but your speed of light. Very, very important. So, having said this, this is the formula for absorption, but when it is reflecting, then it is twice of that. Why? Because one pressure will be when it falls onto it, and second pressure will be when it leaves that. It's like the change in the momentum. If a mass comes and stops, change in the momentum is mv. If a mass comes, stops, turns and goes back, then change in the momentum is 2 mv. So think of it that way. When the light falls and reflects back, then the change is twice. So that's why it is 2I by C. Keep this in mind. So read the question carefully, whether it is reflecting or absorbing surface. Okay? Keep this in mind. Keep this in mind. Yes, 2I by C. Okay, let's start solving some questions. I hope you have noted down the formulas for intensity and for, radiation pressure. By the way, one small note over here. If you have missed the previous class, please check the previous class, because over there I have discussed types of sources. Types of sources, and I had given 3 different types. One is point, other is cylindrical, and another one is planar. And how the intensity is inversely proportional to R square, intensity is inversely proportional to R, and intensity is constant. The same theory is applicable even for light sources. Keep that in mind. Point source is like a light bulb which emits light in all the directions. Cylindrical source, example tube light, which emits light in the form of cylindrical waves. Alright, and planar is something like a flat surface emitting light waves. So these 3 are also valid. Alright, in case of light. In case you have missed the previous lecture, watch it over there. Here comes the next question. There is electromagnetic wave which has intensity of 75 watts per meter square, and the radiation force you have to find on a reflecting surface of area of 2 meters square. So come on, let's see how many of you get this. What is the radiation force which is exerted on an area of 2 meters square? Well, to think about it, guys, if this is my area, okay, the radiation falls and reflects. That means the radiation pressure, which I just told you, for completely reflecting surface was 2 times I by C. Hence, the force which will be exerted will be the pressure, alright, on that reflecting part multiplied by the area. So hence, it will be 2IA by C. Now, if this much is clear, it's just a matter of substitution. 2 times intensity is 75, area is 2, and divided by speed of light, that is 3 into 10 to the power 8 standard value. So 75 into 4, guys, that will make it 300. 300 by 3 is just 100. 100 by 10 to the power 8 will make it 10 to the power minus 6. That's his newtons. So 10 to the power minus 6 Newton, that is option C. That's the answer. Very small force. Do you see how small this force is? It's less than the weight of an ant. So don't expect that I will have a torch and I will turn on the torch and I can apply some force on you. No, it's hardly going to be anything. It's very insignificant. So that's why you do not bounce off when somebody turns on some light. If that happened, that would be weird. And that would be fun too. Yes. I know, Jagdish, don't worry. Whenever the NEET announcement will happen, guys, I'll be doing it on this channel as well. So as soon as the NEET dates are announced, I'll be doing it on this channel. Don't worry. And therefore, everyone out here. All right. Now, let's talk about polarization. That is the last part of electromagnetic waves. And you are going to see a very interesting example in some time. An excellent example. Sunkara Surya, I'm really sorry to hear that, but can you do one thing? Can you just ping me on Instagram or something like that, and or probably type in a comment? I'll definitely help you out. Don't worry, Sunkara Surya. All right, don't worry. I'll help you. Whatever issue you have, please type it out. I'll definitely help you out. Okay, cool. Okay? And we all minions are also there for you. Do not worry, guys. If you are under depression, if you have some kind of thing which you have nobody to tell, all right, believe me, you can tell it to me. I will not tell it to anyone. You can treat me like a friend and you can discuss all your worries. I can act like your counselor as well. So don't worry, guys, we are all there for you, and whatever you discuss with me will stay private. It will not go out anywhere. So that's one thing I can assure you. And I know many of you have already contacted me on Instagram and stuff like that, and you have got your doubts resolved. So keep doing that. It's okay. It's okay. If you have no one, even your parents are not listening, your teachers are not listening, your friends are not listening, don't worry, open up. I'm there for all of you. All right. So polarization. What is this polarization? See, guys, if I take a string and I create some waves, that wave is traveling on this dotted line. Okay. I have a cardboard piece and there is a slit in it. Okay, there is a slit in it. You can see that. If that slit is in the plane, if this slit is in the plane of that wave, then that wave will pass through beautifully without getting affected. The next slit is also in the plane of oscillation, so that wave will travel beautifully without any hindrance. But imagine that slit is made perpendicular. The wave wants to go up and down, but the slit is horizontal. That string won't be able to move. It will be stuck over there because the string wants to go up and down. So what will go on the other side? Nothing. So this is called basically, if a wave is moving up and down, all right, in one particular plane, that wave is said to be polarized. And transverse waves can be polarized. Keep this in mind. Transverse waves can be polarized, and this sheet, all right, this sheet is basically called as a polarizer. It's called as a polarizer. So by changing the orientation of the sheet, one can permit or not permit the wave from one side to the other. If I hold the polarizer in the plane of the wave, all the wave will get permitted to the other side. If I hold the polarizer in the perpendicular plane of the plane of oscillation, then nothing will be permitted. But you might be wondering, what will happen, sir, if I hold it at a small angle? Well, if you are going to hold the polarizer at an angle, guys, this is very important. If this is the wave, okay, and let's say you are holding that polarizer, you are holding that polarizer at an angle, okay, you are holding that polarizer at an angle, then the wave which will come out will be slightly smaller. And if this angle, keep this in mind, if this angle is theta, okay, and if the intensity of light before was I, then the intensity of light that will come out on this side will be I cos square theta, because if the amplitude of light over here was A, then the amplitude of light that will come over here will be A cos theta. And do not forget guys, intensity is always proportional to squares of the amplitudes. So that's why if the intensity is I, on the other side, the intensity that will be coming out will be I cos square theta. Keep this in mind. Okay. So now if this much is clear, think about it. If theta is 0, like in this case, what will happen, guys? If intensity was I here, intensity will be I only. But if theta is 90, then what will happen? Then cos of 90 is 0. So that's why 0 intensity will go over here. So that's how the formula works. Keep this in mind. Cool. Understood? So use this formula very wisely. Now let me show you some beautiful diagrams. Usual light sources, your bulb, your lights, tube lights, car lights, torch lights, LEDs, they are not polarized. That means the light, which is an electromagnetic wave, it never comes in one particular direction. Sometimes the light is in this direction, it oscillates in this direction, sometimes it oscillates in this direction, sometimes it oscillates in some weird direction. So it's in random directions. It's not one particular plane in which the electric field goes up and down. There are random planes, in fact. So that is the problem. So yes, so the normal sources of light are unpolarized. This diagram represents the directions in which electric field oscillates. If I show these kind of arrow marks, that means the light is oscillating in all the planes. So hence it is not polarized. What is it called? It is called unpolarized or not polarized. I hope this is clear. Understood, guys? Is that clear? Anurag, the 11th standard topics are almost done. There is nothing which is left. Let me know which topic is left. We just completed waves. In fact, waves, what we did yesterday was also 11th standard topic, and tomorrow also. So before blaming, please think what you are saying here. So don't just come here and blame things. Okay, cool. So now here is the thing. If everybody has understood that this light is unpolarized, what will happen if you send an unpolarized light through a polarizer? This is what happens. Look at this beautiful diagram, guys. If unpolarized light passes through a polarizer, only those light planes which are in the direction of the polarizer will pass out. All other components will get eliminated. Do you see that? Yes. Look at this. Same thing. If this polarizer has a plane of oscillation here, think of a slit like this, vertical, then all the components other than the vertical ones will get eliminated. Only the vertical ones will come out. That's how it is. I hope this is clear. So keep this in mind, very important now. If the intensity of light over here was I, the intensity of light that will be coming over here will be I by 2. Yes, half of the wavelengths will get eliminated. Half of the waves. Exactly half will go out. That's how it is. Okay? Don't worry, Anurag, we are having all the lectures. Don't worry, and in fact, we have completed all the lectures. Alright, and we are doing it. And in fact, next week I'm planning even units and dimensions also. Don't worry about it. Okay? So, there we go. There we go. Now, keeping this in mind, let's start solving some problems. Okay? So, if unpolarized light enters a polarizer, okay, it becomes polarized. So, remember this one thing, that this light over here is unpolarized. This light over here is polarized. If again there is a polarizer and if the plane matches, it passes by as it is. So if it was I over here, it will become I by 2, and here also it will become I by 2. But here, if it was I, here it will be I by 2 because it became polarized. If the next polarizer is at 90 degrees, the intensity will be 0. Keep this in mind. Cool, cool, cool. Communication system will be done next week, Diya, don't worry. Okay. Cool. Let's get going to the next. All right. Here it comes, the next question. All right. This was asked in 2013. Believe me, this was asked in 2013. A beam of unpolarized light of intensity I0 is passed through a polaroid and then through another polaroid B, which is oriented so that its principal plane makes an angle of 45 degrees. Understand, draw it. Don't just solve it, draw it. That's very important. You will get a sense of it. So, what will be the intensity of the emergent light? Okay. Unpolarized light of certain intensity is passed through a polaroid or polarizer A. Then, it goes through another polarizer B, which is oriented by 45 degrees to the principal axis. Then what will be the final intensity of light that will be going out? Come on, think about it. Think about it. Come on, guys, let's do this. This was 2013 question. Let's see if you are going to write the examination in 2013. How would you write it? How would you write it? Come on, think, guys. All right. So when are we supposed to use I cos square theta? Aishwarya, you will understand it in this question. Exactly in this question you will understand when to use cos square theta. All right. Let's do this. So first, the light which is coming, all right, over here is unpolarized. Okay, so the light which is coming over here, that is unpolarized. It passes through a polarizer, which is A. So this unpolarized light will become polarized. Now, if this intensity was I0, think about it. What would be the intensity here? Wouldn't it be exactly half? Unpolarized becoming polarized. So wouldn't it be I0 by 2? Correct? Now, the next polaroid is at an angle, guys. Yes, it's at an angle. And what is that angle? That angle is given to be 45 degrees. So think about it. The next intensity which is going to come out, what will it be? It will be this intensity is cos square theta. Correcto. This intensity is cos square theta. So a lot of people forget that it was I0 by 2's cos square 45. And cos 45, everybody knows, is 1 by root 2. So square of that half. So it will become I0 by 4. That's the final answer. I0 by 4. Lot of people ended up marking this option B in the exam. They forgot it will become half and they lost marks. In fact, they got negative marks. So be careful. Yes, I know that 2 is missing. I know. So Dhanush, if you are starting 12 portions in April, March, definitely Dhanush, no problem. In fact, Dhanush and others, I have just started the Irodo course, the most difficult problems from 11th standard course, and this course has started on Monday. Every Monday and Tuesday 4 o'clock I have started and I have received tremendous response. I'm really glad so many of you could also make it over there. So if you are in pro subscription, this course is for free. Also, I have started revision of 11th standard problems on the paid platform, of course. All right. So all those courses are for free of cost. So you can go ahead, join the pro subscription if you are a 11th standard student especially. All right. So let's get going. Now, I naught by 4. Last thing over here. Now, this is a beautiful law, guys. Beautiful law that is going to come up. Now, here it is. If unpolarized light falls on a refracting surface, one medium, second medium, unpolarized you can see, then the light which goes inside the medium is still unpolarized, but the light which reflects is polarized in a very special situation. What is that special situation? When the reflected ray and the refracted ray are perpendicular to each other. The refracted ray and the reflected ray are perpendicular to each other. That is called as Brewster's law, guys. That is what you should remember. Yes. So Brewster's law says that the reflected ray is polarized when the reflected is perpendicular to refracted. And that happens when tan of angle of incidence is refractive index. This is Brewster's law. Very important. Now you will be wondering what will happen if the angle of incidence is not exactly equal to mu. The tan I is not equal to mu. Then it will not be completely polarized. It will be partially polarized. That's what will happen. Correct? So it will be partially polarized. I hope this is clear. All right. Cool. Let's get going to the next thing. Now I'll tell you the beautiful application of this. See how the unpolarized light is coming over here. It is falling on a glass or a transparent medium. Part of it is getting reflected. Look at how that reflected light is, guys. Isn't it polarized? Do you see that? Diya, virus alert means somebody is trying to intrude the minion family. Yes. Diya, I have also taught all the topics. Forget easy kill. I have taught hard kill topics also, Diya. Everything is in the playlist. Please, guys, if you are new to this channel, watch our playlist, at least the physics playlist. I have taught all the topics. Few topics which are remaining, I'll complete it by Sunday or Monday, Tuesday. Don't worry about it. Yes, that's how it is. Now, the application of this is that when you are outside, sunlight which is coming is unpolarized. That will fall and it will get reflected. Isn't that polarized? The sunlight which will fall on different surfaces around you, snow, water, land, etc. It will reflect, it will be almost polarized. Now, the moment it is polarized, that's a very interesting thing to note, because that reflected rays is a torture to your eyes. You do not want it. Nobody wants those reflections falling on your eyes. And especially if you wear shades or goggles or specs, etc. or contact lenses, that glare is not a decent thing to have. So that's why you have polarized goggles. So I'll tell you what happens. If your goggles are non-polarized, you will see all the reflections coming in. This is a normal glass, but this is a polarized glass. That means the light which is going to enter, that plane is perpendicular to the glass plane. Yes, the glass also has tiny slits, think of it that way. So it is perpendicular to the plane of polarization of the reflected light. That is why all that reflections get eliminated, but all the other things will be seen by you. That's how it is. So this is the advantage of a polarized goggle. Look at this. Without polarizer, all the reflected light is coming in. But with the polarized lens, you can see all the reflections just go away. You can see that. I hope this is clear. So how many of you wear spectacles and how many of you knew about this? Amazing. Cool. So this was in fact a question in 2014. They gave Brewster's law. The angle of incidence at which reflected light is totally polarized is which one? And the answer is obviously tan inverse of mu, where n is the refractive index. Such a simple question came in 2014, guys. Direct question, Brewster's law. Just imagine. No, Arpit, this is not there in JEE Advanced. Yeah. Oh, so many of you are wearing specs. Okay, okay. Frederick, Shavana, Princey, Dinesh, Yalini. Wow, kya baat hai. All right, very good. Yeah, such easy questions are also asked. That's why I said, do not leave this topic. If you miss one formula, also gone. You'll lose those marks. Free marks, 4 marks. Why do you want to lose it? That's why I'm telling you, study this chapter. So, some homework problems for all of you. Alright, they are also with the solutions. This is your first homework problem. The plane of EM wave, so and so intensity, it's given. Alright, answer and solutions are also mentioned. This is the second problem, homework problem on Brewster's law. And then your third homework problem of 2012. Very important problems from this chapter to make sure you have understood it. Make sure you solve these problems at home and check your solution later on, not before that. And if you want the entire solutions, guys, it will be posted on the Telegram group tonight. So check it out. Join the Telegram group if you have not joined it yet. And do not forget, for all those 12th standard and dropper aspirants who want to clear JEE, the crash course has already begun on Monday. You just missed a day. You can watch the replay and join the crash course. It has 11th and 12th revision with 20 test series, live doubt solving before and after the class and in the class. Also, special sessions by important people around and who will guide you through the strategies and tips and tricks before the examination. So that's very important. So all of this at a very affordable rate of 10,000 rupees, but after discount, understand, you will get it for only 8,000 rupees. The batch has already started on 8th. Do not miss it, because the more you delay by one week, that's it. You will have to wait for one more week for the crash course to end. So join it today. Do not wait. The link is in the description box below. And for all the minions out here who have spent all the time, yes, so do not forget to subscribe if you have not done it. I'm pretty sure you have done it, but still. And do not forget to hit that like button out there. Yes, do not forget to hit the like button out there. So I hope you had a lovely time. See you tomorrow and another important session of Doppler effect, beats and standing waves. All of this will be covered tomorrow in a marathon session. So get your snacks ready. Bye bye. Take care. See you.